Now I'm pleased to introduce our second speaker for today, Professor Michael Benedict. He's an ACSA Distinguished Professor of Architecture at the University of Texas, Austin, where he holds the Hal Box Chair in Urbanism and teaches design studios as well as architectural theory. Among his numerous books, In Architecture for Reality, Deconstructing the Kimball Cyberspace, First Steps, God is the God We Do, and God, Creativity, and Evolution. Between 1988 and 2017, he edited 10 volumes of Center, Architecture and Design in America, and published over 120 articles, papers, and books, some at mbenedict.com. His most recent book is Architecture Beyond Experience, published in 2020, and he is also responsible for the Easovist theory, the software for which is available at easovist.org. I welcome Michael Benedict to present Meditations on Size and Number.
Yes, greetings. Can everyone hear me? Okay. Thank you. The lecture is a brand new one, and I've never given it before, so there's no telling how long it's going to take. It's a fairly ambitious lecture, and it's also very theoretical, to be honest. And after listening to Anupama, I want to rewrite it because of how very theoretical mine is. But hopefully, between me and Anupama and David, we'll fill the matter in somewhat. So I'm going to hopefully not have trouble with screen share. Let's see how that goes. Can everyone see my first slide? Okay, good. As you can see, I changed the title just a little bit. I added the word similarity because it turned out that in order to talk about number and size, I had to talk about similarity. So let me begin here. We all depend on the ability to count. All of arithmetic, all of mathematics, all of business, all of engineering depends on our ability to count. And there's very interesting history, anthropological history, of how we learn to do basic math. So I'm going to go through some illustrations of that. This arrangement of the numbers 1 through 6 on gambling dice, on dice. It's interesting at several levels. We can tell what it is that's being repeated. It's the little black dots. They're in a very strange order here, which I have not actually figured out how they laid these out. But let's ignore that for the moment. 1 through 6. Teaching children how to count is also a very interesting process. This is from what's the name of the educational system? Oh, anyway, we're learning here how to count using sticks, where we're trying to connect the tactile with the quite abstract notion of number. We also count with our hands, and here we see an attempt to sort of formalize that, so that we have 10 fingers. I'm sure this is where counting began, and where our hexadecimal system comes from. It's from the 10-ness of our fingers, grouped into 2 groups of 5. Now, something interesting happens when we get beyond 10. For example, when we see numbers like this as perhaps a multitude, and we can only start to guess at what the numbers are here and how the grouping is being done. Numbers here, in this case, books on shelves, arranged, we don't exactly know how, but the numbers are becoming uncountable. And similarly, when we are dealing with large numbers of animals, or in this case, of course, people. Now, I wanted to look at that sequence and sort of argue that more than one thing is happening as we went through those slides. So in this last sequence of images, 4 things are going on. First of all, we're doing grouping. And we're grouping for different reasons and by different methods. And I think for an architect, which is where this is ultimately going to lead, the reasons for making things in groups and the reasons for putting them together are different. And each of these slides actually has a slightly different theory of why things are together. Secondly, the number of objects being grouped and shown is increasing, right? We went from 6 to 9 to 10 to hundreds. Of course, the number could go higher if I showed you pictures of the stars or something. The third thing that's changing is the number of qualities of each individual object is increasing. So if we look at the dice, we're going to go, those are little black dots or little black dimples in wood. They are effectively identical. It'd be hard to distinguish one from another. When we look at the sticks in the box, they are actually, I think, handmade and a little different. Same with hands. When we go to a vegetable market, we will pick the ripe fruit from the unripe fruit, the better looking from the not better looking. The books themselves, the number of qualities of each book, given that they contain hundreds of pages of different texts and images, no two are really the same except trivially. And of course with people, as we have it in Jewish lore, every person is a universe to themselves. And so the counting of people will always be slightly problematic. And 4, the number of relevant qualities of each object is increasing. Okay. Now, those processes, I think, are really worth looking at because they will have architectural consequences. There are logical reasons for how we group, how we count, how we come up with sets, what set theory is, what logic is actually. Now, in the face of that, we also have psychological limits. And psychologists have discovered 2 limitations in the human processing system, since we're actually not very good at numbers. And there are 2 processes that we can talk about, which will apply later on. One's called subitizing. Now, subitizing, I'm going to just throw a whole bunch of text at you here, is the rapid, accurate, and confident judgment of numbers performed for small numbers of items. It was invented in 1949, and it captures the feeling of immediately knowing how many items lie within a visual scene when the number of items falls within subitizing range. Sets larger than about 4 cannot be subitized unless the items appear in patterns, which we'll talk about. It turns out, as I've done some research into this, that animals subitize, primates subitize, and it's true that most mammals can actually count the difference between 1, 2, and 3. There are cultures, human cultures, that actually do not have a number system beyond 1, 2, 3, many. They don't go further than that. So subitizing or subitizability is, I'm going to argue a little bit later, an essential part of the architectural task. The second psychological limitation is called chunking. And this came out of a paper by George Miller in 1956, and you might have heard of it in various times. The magical number 7 plus or minus 2, some limits on our capacity for processing information. It's one of the reasons why phone numbers are the length they are and no longer. It's one of the reasons social security numbers and ID numbers and credit card numbers have to be grouped into smaller bits, because we can actually only deal with about 7 items and remember 7 items. And as you go into what this process of chunking is about, we realize that we've developed many, many strategies to keep things within the chunking limit. So if I put those two together, you get something like this. 1, 2, a couple, very easy to do. A few is a word we use for 3. I'm sure there are Hebrew words for all of these. I'm happy to let anyone add what they are. I think in English, we use the word several for 5, 6, and 7, then many, then very many or too many to count. Like when you see more than about 15 objects, you cannot count them all at once, and you'll just start waving your hands and just saying a whole bunch or too many to count. You can see the first chunking limit is around 6 to 7. And then you start grouping, so that 8 is 2 groups of 4, 9 is 3 groups of 3, 10 is 2 groups of 5, and so forth. Now, this is a very, I think, essential process. And I think we do it all the time. We do it subconsciously. Wherever we go, we count. We count the blades on the ceiling fan. We count the number of wings in a building. We count the number of windows in a wing. We count the number of steps we're going to have to climb. Keeping the world accountable and within subitizing and chunking limits is part of what we mean by human scale. Okay, and a wise architect, I think, is one who makes sure that the building is subitizable and chunkable. Matters go a little bit deeper. So I want to go back to the first factor in the 4 that I mentioned earlier, and look at reasons for grouping. Okay, I think, and if you think about it, you'll come up with roughly the same analysis. There are 3 reasons we group things together. One is by virtue of their similarity. We decide that this group belongs together. That's how we make sets, is by groups of similar things. When an architect gets a program, we often will look at the residential wing, the shopping, or what have you. Items are grouped by similarity of function, similarity of form, something like that. And they seem to us to belong together. And we will often make groups because of visual or functional similarity, which are not actually groups. They are forced. It's a similar process to curation, where objects are collected from all over the world, let's say, and put in the same room on some theory of similarity, that they belong together, whereas they were not found together necessarily. So that's what a curator does. The second process is enclosure, the third, affinity or relation. So let me just go through those a little bit, because I think, so this is a grouping that's on, that has 2 reasons for the grouping. Similarity, that is, these fish recognize, well, actually, this is more like affinity or relation. They recognize each other as the same kind of fish. We group them together, and we call them a school of fish, because they're all the same species. And if we were to museumize this, we would try to put them together as well. But from the fish's point of view, every fish is just trying to be next to another fish. And when 1 million fish all decide that they need to be close to fish that look just like them, you get a group that is formed from internal relations. However, we can also group by enclosure. So if you take a bag or a bucket or something and pick up trash, or you throw things into a box or into a room, the mere fact of their enclosure will make a group of them. Okay, and so you can have a box of miscellaneous things, where the very idea of miscellany or miscellaneous means there is no natural grouping and there is no affinity grouping between these objects. They are merely thrown together or blown together by the wind or by chance or by force. Now let's look at similarity a little more closely. When we ask whether two, in this case, primates here are similar, but we could also say, you and your cousin, or 2 cups of coffee. We do mathematically, but also intuitively, we do something of a process. And that process looks like this. Item A and item B have a number of attributes, okay? We could, if you were very, very precise about this, find out the number of attributes you're going to be interested in, check whether the item A or B has it, and if they both have it, score it as a match, okay? So in this particular case, we have a similarity score of 0.333. That is, on the same list of attributes, we have decided that they are similar to this extent, 0.333. Now you'll notice that the number of attributes here, I just made N9 to make it subitizable. We don't know how many attributes objects have. Most objects have infinite numbers of attributes. Part of what Anupama was about was telling us over and over that common objects like trash or recycled things and natural materials have attributes that we are not using, and that we can recount them and redo them in a way. But the fact that we identify objects by their attributes is a very interesting one. Sorry to do math here, but this is the last of the math, I believe. So here's what you get. P sim AB is the probability of the similarity of A being similar to B. If the similarity is 0, each object is unique. If the probability is 1, then they are identical. And you'll notice that the probability of 2 things being identical goes down precipitously as the number of attributes go up. Because 1 over 2 to the n gets very, very large if n gets large, okay? So that's saying that in any group of objects that has a large number of attributes, each one, the chances of picking up any 2 as being identical gets close to 0, okay? And it also tells you that if you pick 2 objects at random from this group, there's at least a 50% chance that they will be more than 50% similar. And that might not seem like a significant fact to you, but someone called, Leibniz thought it was very interesting and made this claim. He called it the law of the identity of indiscernibles. What he said was that any 2 objects that are absolutely identical cannot be 2 objects. They're actually 1 object. That the reason that there are more than 1 object is precisely because they are not identical. They are not identical. If they were identical in every way, they would be 1 object. That's a highly philosophical principle, but let's just see what it is here. No 2 distinct things exactly resemble each other. This is called Leibniz's law. No 2 objects have the same properties. It raises tremendously interesting problems all the way down to quantum physics. But here's what it means. The bottom line is that the universe is only as big as it needs to be to allow for the differences it contains. Why is the universe as big as it is? It's as big as it is because it is differentiating and becoming more complex and more various. It means that in the beginning, there was not 1, as the Bible says, actually, but on the second day of creation, or first day of creation, when there was 2, that the 2 were different and yet in relation, entangled. It means that where differences beget differences, the universe expands. And it means that the universe's substance is neither mass nor energy, but information. As John Archibald Wheeler put it, its come from bits. Every it, every particle, every field of force, even space-time itself, derives its function, meaning, existence entirely from the apparatus elicited questions, yes and no, binary choices, bits. It from bits symbolizes the idea that every item in the physical world has a bottom, a very deep bottom in most instances, an immaterial source and explanation. That which we call reality arises in the last analysis from yes-no questions and the registering of responses. All things physical are information theoretic in origin, and that is why we have a participatory universe. Now, he was a quantum physicist, and I think it's reasonable to ask what this means for architecture. I think it means this, that a building is only as big as it needs to be to allow for the differences it contains. I think it means that architecture begins in two-ness, in comparisons and companions, in living relation between entities like two rooms, or a room and a tree, or a person and a window, and not between general conditions like inside and outside, or the natural and the artificial. Architecture is full of binaries like this. And I think it means that if the substance of architecture is information, then a comprehensive theory of architecture deserving the name has yet to be forged. Now, I'm the second part of the lecture. I don't know how I'm doing on time here. How am I doing on time, Tom?
We have about 5 minutes.
Only 5 more minutes?
It's between you and David.
Okay.
Okay.
I'm going to race through this.
Okay. Thank you.
I contrast here the souk at Aleppo with the CCTV building. Now, clearly, this is about scale, but it's more than about scale. It's about the fact that the building on the environment on the left is just at the threshold of chunking and subitizability. The number of people, the number of tags you can see, the number of arches and arcs, the number of roll-up screens in the doors, etc., are all at the very, very edge of countability and parsability. Whereas here, we see something that's very much an object, a singular object. What's more, an object that seems to be manipulable by the hand. What do I mean by that, since it's an absolutely gigantic building? What I mean is the origin of its form is the appeal to, I think it's very much like an executive toy. You know, those sculptures, those fiddle things that you play with. You want to pick it up and turn it upside down and sideways. So what's going on here is a play of scale. An extremely enormous object has no subitizability. It has no groupings. It is simply a singular object, which blown up to, a manipulable object blown up to an immense scale. And I think you'll find that's OMA's signature, actually, to make buildings like that. It's also true of ZHA. What is needed? I'm claiming new theory, okay? I've tried in my own work, which I cannot present here too long, to actually get to that using isovist theory, which I've asked you guys to look at through isovist.org, the idea of M-brains, which is ways to partition space without doors and walls. There have been spaciousness studies. Spaciousness has a great deal to do with scale and why spaciousness is valuable. It's for economic and real estate reasons. In discussing relationships, there's something called the fabric of glances, in which is how people look at each other and find each other, creating a continuous fabric of basically people looking. The idea of onto-relationality, which I think is a a reconception of space and object. But I'm not going to try to convey all that here, but rather end with an architect who I think pointed to the future. Design, Louis Kahn said, is not making beauty. Beauty emerges from selection, affinities, integration, and love. A lot of people take Kahn's pronouncements as sort of impish and full. I think they're actually quite scientific, and would prove that for you. So here are some Kahn projects where I see this happening. An early housing project. He was just becoming the Louis Kahn we knew. You'll notice that he takes the multiplicity of housing blocks and immediately groups them into 6, actually, with the 1 being the driveway. Block number 4 is different to blocks number 6. So that, and if you look at the views out of the backs of those blocks, they're always into a garden. And it's an absolutely brilliant permutation. But notice that he breaks it down into comprehensible, subitizable chunks. The same here with Unitarian Church, although the outside exceeds the ability to sort of group and count. If you look at the core, and we see the 4 skylight monitors that seem to face inwards towards each other and in a certain way to hold hands, like 4 people holding hands. I claim that the inspiration for that was a picture of a grave in Morocco photographed by Aldo Van Eyck, where we see again the 4 individuals, as it were, grouping around a sacred space. If we go to the Salk Institute, we see a gigantic building broken down into 5 on a side, library studies. Each of those is broken down into 2, so that we get 5, you get 2, 5, 10, 2. The groupings we're seeing here are incredibly legible and memorable. And yet when we get to the bottom, their multitudinousness seems to add up to something, to like a sort of an infinity. I think that was an absolutely brilliant stroke of design. I am moving quite quickly now. In this particular grouping, call it a social grouping, I think we see the logic of the building at Dakar. And if those of you who studied this building know that it's all grouped around the hall of meeting. I became especially interested in these office building blocks, which you can see in the center at the bottom. It's the 2 sort of L-shaped 2 rooms that are joined at the corner. He used that again later on in the Mother House and several other projects. But they both look together at a courtyard. And what's fascinating about this arrangement is that we see 2-ness working, the 2-ness becoming 4, becoming 8, becoming 16, etc. But also the fact that you can be in one of those rooms, look through the windows and see the outside of the other room, as well as the inside of the other room, as well as the common space, as well as the city. And I thought I would play for you a simulation of what it's like to be there, because you're actually not allowed to photograph it. I hope this is playing smoothly for you. This is was done by John Zott of Brooklyn Digital Studio. So we see the outside of the room, we see the inside, we see the wrong people on the wall because this is Bangladesh and not India. We can see back to the other room that we saw the inside of. We see out to the common space, catching the sunlight and the city beyond. So I think of that as a brilliant piece of design. Here he is at the Herva Synagogue, which I'm sure many of you have studied more than I have. It's a building that was not complete. He had enormous bridges to cross with this, especially with sealing it against the weather, which would have changed everything. But I think you can see the numerology working again, always keeping a building to within subitizable and chunkable boundaries. Probably my favorite building by Kahn is the Exeter Library. The scale of this central space, I'm sure it's one that we've all looked at and admired. That central space is only 10 meters by 10 meters, okay, which is hard to believe. And yet the monumentality of it is completely domesticated. It has an absolutely uncanny feeling when you're there of immensity and intimacy. It has a kind of an intimate immensity with with dead acoustics because of the sound absorption of the carpets and the books and so forth. So the combination here of great space and domestic space was absolutely extraordinary. We look up to the center, we see 4 or 2 crosses, 4 wings, 9 bays, 4 roof vents. To look at this is to be launched into comparison and counting and comparison and counting that will not end. The implications here for knowledge, book knowledge, which all those inner counters have, looking into the universal, the absolutely microscopic fine print. Every scale is represented in this drawing, including in this view, including human scale of the woman across the way there. This is a building, I think, that can only generate exactly what he asked for: beauty emerging from selection, affinities, integration, and love. Thank you.
Thank you so much, Professor Benedict, for this fascinating meditation on scale and Louis Kahn.